All right, the recording has been started. Welcome everybody. Thanks for joining us tonight. Um, I didn't have anyone sign up for a topic tonight, and so I went back and I looked through the list of topics that people have asked for when they sign up for the mailing list. There's an option to say, here are the things I'm interested in. I haven't pulled that list in a while, and we've been doing a good job of kind of shrinking that topics list from, I think the last time I looked at that was sometime in January. But one of the things on there was just programming. And coincidentally, in the last week or two, as we're scrambling to get new things into the code, and we've got more and more students working on things sort of in parallel, or you go try this and you go try this, and then trying to figure out how to pull it all back together. We've been running into some things with new students that are new to code this year that aren't familiar with the Git process. So we've had a fair bit of Git stuff internally to KnightKrawler. We've been struggling with April tags. Before I started the recording, Eric from Talon was just talking about some of their April tag troubles. And so I think it'd be great to talk about some April tags tonight. Other things that are sort of coming up is talking about some of when you build your autos, the different groupings. So sequential is, I think, kind of obvious to everybody, but there's parallel group, parallel deadline group, and parallel race group. And those can be really helpful in certain situations. And I think it would be great to get some clarity around that for anyone who's new to building complex autos. And so we could maybe do a little bit more path planner stuff. Ever since we did our path planner talk a few weeks ago, folks have been finding it on YouTube and they've been emailing us for more path planner questions. Fomi's here tonight. So hopefully Fomi can answer any path planner stuff. We've also learned a lot about path planner. When we gave that talk, we hadn't been able to run our autos at all yet, and now we have. And so Fomi has, I'm sure, learned a lot of new things, and so we can share some updated advice in that if we want to. I really want tonight to be sort of an open topic, fair game. We're struggling with this, or we just had a breakthrough and we want to share advice for other teams. And so that's my goal for tonight. Before the recording started, Eric was talking about April tags. I feel like that's a great place to kick it off. So, Eric, do you want to give us a summary again on what your students have been struggling with and your fellow friend team that you've heard from?
Well, I really would like our programmer to. I'm talking everything secondhand, so our programmer, Andy, I hope he can give a better insights than I can. Everything as I say, is from things I hear from him and from the other team. So see if he's willing to talk about it.
Well, I personally haven't worked directly on our vision code. I've delegated that. But we've gone in 3 separate directions with using photon vision, which is what we did last year. But we were having issues with it. The performance of that wasn't something we were super happy with. We also went in the direction of using the WikiLib April tag library in C++ to kind of roll our own April tag code. On that front, we had issues where whatever we tried, it was always off to some margin, especially in terms of rotation. I don't know if that's a code issue. I don't know if anyone else has a experience using the C++ April tag library. Okay. And then the third direction we were going was using the Limelight 3s, which in our case also wasn't sufficient. So currently we're just using NavX and known set points for our tracking and tally-up, and we're only using odometry and auto.
I will share that KnightKrawler, we had April tags working okay in the shop, and we went to Duluth and nothing was working for us in Duluth, and we ended up we put an if statement around our April tags for the close estimator and said, if we're in auto, do not let close estimator update using April tags. So we were running pure odometry in Duluth for our autos during week 1. Similar issues where we just couldn't trust the April tags. I think what we were seeing there was that when we were in the shop, when we would run an auto again, our driver, our programmer, our driver would drive the robot up to the subwoofer where we would start. And the process of driving up to the subwoofer, the camera would be able to see the April tags, and it would be able to reset its odometry and get its position off of an initial pose estimation. But when you put the robot in the field and you turn it on, the camera could not see those April tags, and it's when it's up close to the subwoofer. And because photon vision didn't have an initial reference, it was telling our code that the robot was at 00, which is the top left corner in the blue field. And so it was trying to drive its first route, thinking that it was in the corner of the field. And we could see when we were brought up Advantage Scope that has the map of the field and it shows you where your robot is. We could see that the robot was in its starting position because our autonomous would have a starting position. And so it'd set the starting position. And then as soon as auto would start, it would jump over the corner and think it was trying to drive from there. We don't know why. We think that's a bug in photon vision. And we talked with a lot of teams and they seem to say, yep, we've seen that bug too. We had to turn off April tags as a result. And I don't know if that was just an initialization problem or if that was an every time problem. We didn't use April tags. We only used it in teleop. And so we were only using it when we were trying to aim. And so it could always see the April tags when we were aiming. And then when we came back, we updated photon vision to a new version that had come out. And so I don't know if the reason we're not seeing that is because we fixed our code. If there was an update that solved that problem, I just can't answer that at all. Anybody else want to share what's going on with their April tag code?
Yeah, we had similar issues with auto and April tags. One of those issues that was key at we were at Northern Lights was they had a light shining on the April tag, and because the field April tags are reflective, it's shown a reflection across it. And so if we set up during auto, our robot would not know where it was until it would enable. So that kind of didn't work so well with our autos that are supposed to like intelligently know where they start by path planners like feature where you can start it anywhere. So that wasn't working. Another issue that we had was our camera that we were using. The focus lens shifted in practice matches, and so that threw everything off for the event for us. Since then, we've hot glued it. Basically, we had never been hit so hard that it had shaken at all, but by refocusing it, it changed the calibration matrix. And we were worried because it was like, okay, well, our shooting's working now. If we fix the camera, then our shooting probably won't be working. And so we tuned for 5 spots in 5 minutes and ran with that for all of playoffs, and it was pretty good. But that's been a big issue, as well as the auto issue, certainly. We had a problem where our camera, we have a relatively wide FOV camera on the front of our robot, and for Duluth, we only had one. So it would see the April tags fine when we were really close to the speaker, but if we were moving, and especially further away, as we neared the wing line, it would lose sight of that and sometimes put out really bad estimates. So that could mess it up a little bit. We didn't run into that so much with Path Planner, but when we swapped to Choreo, which we're planning on using for our next event, Seven Rivers, it was moving so quickly that the robot would not be able to get a good track. Turning that off fixed it completely. The other thing we've done to fix that is we've added a second camera with a much tighter FOV to look at the April tags from a further distance. We've got our shooter tuned in now so it can shoot wing line or even further, but our cameras couldn't see that far. So now we have a second camera looking, and that's helped a lot.
Eric, going back to one of your points about somebody upgraded photon vision and nothing was working. We also ran an update that was 2 days or 3 days before we left for Duluth, and everything broke. And so we rolled everything back. I think that we do know for sure that there's a version issue where if you update the photon vision library in WPI lib, you have to have the same version running on your processor, your Pi, and the vice versa. So the version numbers have to match. At least we're pretty sure that was one of the problems. But within 20 minutes, we just aborted and we rolled back our version numbers. And we had a conversation about updating libraries a day or 2 days before you leave for competition and why you should never do that. So it
Yeah,
could have been a version mismatch, maybe.
as I said, I just talked to mentor for the team, and uh, again, this is all second, third hand, but as I said, they had everything working, and then did updates, and they gave up on all the vision they had working previous to their tournament. So I think one of the questions for everybody is, what versions are you allowed? Do you have to update, or how far can you go back to things that are working, right? I know there's certain requirements that you have to have later versions when you compete.
There's no
I,
vendor dependency requirement as far as I'm aware. It's just your Rio has to be on whatever they publish as well as your driver station. You could run a Photon Vision from 3 years ago if that's what works. Nobody will even know.
I'm talking more about compatibilities between the WikiLab versions and the Rio version.
Yeah, this is Wade. I'm a CSA, and I don't think there's any chance that you can run anything but the current release of the Rio version.
There were 2 releases this year. You can run either one. The second release was more for LabVIEW teams, the Rio releases. And then WPI Live, there were 3 releases. You can run any of them. The second one had some network table fixes, which I would recommend, especially if you're doing, April tags. The third one, I think, just reports more information to the FMS.
And along those same lines, I believe there is a third release of the drive station, and as I recall, it is optional. So any of the 3 releases of the drive station are valid.
That's good to know for me, because the second Rio image release completely broke our Rust bindings. But luckily the first one is still working. I still haven't gone to the bottom of that one, but it's good to know that we don't need to get it to run on the second Rio image.
Out of curiosity, what are you running with Rust on your Rio?
The whole robot code is Rust. I think we're on our 7.3 right now of the interop layer, but currently our main robot code is pretty stable. We are running into some performance issues with that. Our refresh rate is less than 50 at the moment. But
That's really cool to hear that you've got it working, Andy. I remember months ago you were telling me that you were planning to do that, or you're working on that. So good for you guys. That's a tall task. So I don't want to go too far away from the April tags topic, but as long as we're talking about versions, and we've got CSAs and other folks on the call that know a lot about this, I'm curious about the upgrade that sends more information back to the driver station, because I feel like network latency can be and often is a big problem, especially if you're sending back 2 camera feeds for your drivers. And I'm curious to know, if you're sending back more diagnostic information, has anyone reported or seen issues with having more network latency as a result of sending more diagnostic info?
I haven't seen any firsthand impact for latency in particular, because I suspect that the photons do a good job of doing compression. So I think with the vision, with the actual screen images, or camera images going from the photon to the drive station, that as long as the compression is set well, that you're dealing with CPU time on the photon and CPU time on the drive station, and the network latency should not be a huge impact. I have not specifically looked at that to confirm, what types of compression are good and bad and so on. But
Okay. No, I'm glad to hear that you haven't heard anything. I haven't noticed any network latency issues with our robot yet this year, although I have to admit that I haven't been looking very closely. And sometimes if you don't ask your drive team, they don't offer up that information. So I have no idea. If no one else is having issues, then I suspect we're in good shape. Back to April tags. Afomia, do you have questions specifically about April tags based on how our Saturday went this year? I know that we ended the day not super happy with our progress.
I'm not sure if I have specific questions. Just again, we're still having problems with April tags messing up where the robot thinks it is during the path, at the beginning of the path, at the end of the path, everywhere really. So I kind of just want to know if other teams were having problems with that. It sounds like they are, but
I'm
I
curious.
guess.
Go ahead. Sorry.
No, sorry. Go ahead.
No, I would like you to finish your thought.
Sorry, my audio just cut out. I was just saying if anyone found any even like temporary solutions, if we could like build off of that or anything that kind of seemed to make it work better.
I will add to that. One of the things that I'm thinking about following our Saturday. Let's give a specific scenario. We are working on an auto that picks up, shoots the one we have, picks up close, runs out the center line, comes back, and the plan is to shoot a second one. And when we come back and we shoot our note that we picked up off the center line, we're about 3 meters away, and it's missing a meter to the left or a meter to the right. I think it's to the right. So it comes back and it's consistently in the right spot, but the heading is pointing the wrong way.
Yeah. Another thing with the heading is we noticed with that same auto, we noticed that at the beginning when we were running the path, it was supposed to be backing up and rotating to the left towards the speaker because we started off kind of to the right. So we were moving backwards to the right, and it was meant to rotate to face the speaker so that we can, shoot. But it ended up turning like more to the right, facing away from the speaker. So again, like the horizontal rotation is very much thrown off by April tags.
Yeah, and we're using Path Planner. So this is a Path Planner path. And while it's driving the right way, the heading seems to be wrong. And we're really confused. And if we turn off April tags, the headings are better. We don't have the accuracy that we want on the field in terms of XY position. But the heading is better. But then we're not driving to the points that we're really trying to get to. And so we're really confused about how April tags are messing up our heading and throwing off our rotation. And if anyone has any thoughts.
I'm curious if people are confusing it looks to me like Path Planner has a fairly strict, consistent use of terminology. The heading is what direction the robot is moving versus robot rotation and the rotation targets, which direction it's pointing.
Okay. So what you just said, Wade, is what I was trying to say is that we're rotating, we're driving the robot, but we're also having that rotation specified on the path. And so which way it's pointing, its rotation, not pose 2D. That pose 2D seems to be off for some reason, and we're really confused. And I suspect, and maybe other people can sort of support this idea or discard it, but I suspect we have to do a better job with our camera calibration. Maybe we need to go back. Maybe we need to tweak some of our settings or something to read the tags better. I'm just not sure what to try next. I was thinking maybe on Monday that we need to change our path so we get closer to the tags. And if we get closer and our rotation is correct, that might be a good clue for us that it's a problem with reading the tag. I'm just not sure what to try next.
Does it work in teleop?
Yes, sort of. I mean, we're having problems aiming at the speaker in teleop as well. We just found some code that another team had shared in their open repository for aiming. We're having an oscillation problem, but it's generally oscillating at the speaker. So I think we're okay there.
I do wonder, one thing that it could be is how you're filtering the position. So like, for example, if we boot up our robot, it's in the middle of the field at a random angle, it'll initially trust the gyroscope. We're using a Kalman filter, and it'll slowly adjust to what the April tags are reading, which means that initially after you turn on the robot, it is incorrect. So I wonder if updating your odometry in disabled will help with that, because we found that fixed our issues pretty easily, because it means that by the time you're actually starting the match, the robot knows very well where it is.
If it can see a tag at its starting
Exactly.
position. Yeah.
Yeah.
What the big thing? One of the things we did was we just turned on the standard deviation after doing the pose estimation, just cranking it super high on the angle and just not trusting it from the tags because our gyroscope's so good. We just found that like we ran it a bunch and the gyro just doesn't drift that much, and so I can take one whole variable out and just use the tags for X and Y. That was pretty helpful. And then the other thing we tried was our standard deviation on the XY. We scale it based on the distance squared from the tag. So basically, like when you're really close, trust it a lot. When you're far away, trust it a lot less. And that went a long way for us. We did end up turning it off in auto because it wasn't better than odometry, but in teleop it's working really, really well.
So since
we also don't use April tags during auto. The last 2 years we used April tags a bunch during teleop, but we don't use them during auto because odometry is usually good enough. We did have some trouble driving out to the center. Sometimes it was falling short. We didn't figure out exactly why that was happening. But one thing to look at is how are you filtering the April tags to? Like what's your decision cutoff? And then, like Sam said, you can filter it based on its distance or attune the standard deviations. But we also decided to throw out anything over 5 meters when we were calibrating. We put it on the field, and sometimes we would see it would pick up just one tag on the stage. And if you only see one tag from farther than that away, it gets very far off. So we're filtering those out. Also trusting if you see multiple tags and you have multi-tag on, you can trust multiple tags more than you can trust one tag. If you see one tag, you should probably not trust it if it's very ambiguous.
So since tonight is all about code, are any of you that are talking about changing your standard deviation willing to share a screenshot or bring up a screen share and show how you're doing that filtering in your code, or even just write some code on the fly or bring up the documentation? I will admit that historically I've been a programming mentor for the team, but this year I spent most of my time working with the CAD students. So I'm coming to our code literally a week into our new code, and April tags is brand new to me. So anyone willing to share some actual coding advice?
I can share what we do. We don't scale the standard deviation. I have seen a few people do that on Chief Delphi, but I can pull up what we're doing.
It's fantastic. I'd love it if anybody here wants to share, like show some actual code tonight. I think this is a great time, a great meeting or great roundtable to do that. If you're willing.
Yep, ours is a mess, but I'd be willing to share too. Our season's over, so it's time to share. So.
Oh, excellent! Yeah, anything that you guys are willing to share, I think everyone would appreciate seeing the different approaches that folks are taking. I know I certainly would.
If I can figure out how to make this bigger. There we go.
There we go. That looks good.
Okay, yeah, so here we get the latest photon result. We're using photon vision. Mm-hmm. And then you can check if it has targets. If it doesn't, you don't want to proceed. Here it has this easy has targets. With Limelight, it's not as easy, and sometimes people miss that early on, checking if it sees a target. If it doesn't, it just tells you it's at 0, 0, and then you start putting that into your estimator and things get crazy. But here we check if you can see more than one tag, then we proceed. Or if you can see just one tag, then it has to meet an ambiguity threshold, which we have set to 0.2. There's also a slider in photon vision where you can adjust your decision cutoff. And we usually tweak that during calibration time. And then here's where we say if we're only seeing one tag, get that tag, is it more than 5 meters in the X direction in front of the camera, and then throw that out. And then the other filter that we do is just check if the pose that it gives you is on the field, like total sanity check, just to say don't feed that into the filter if it thinks it's off of the field. So we do fairly basic filtering that way, and that seemed to work pretty well for us during teleop. During auto, it still jitters around, and so it's funny to run paths with April tags updating all the time because it'll jitter around. We talked about maybe having it be a scheduled, named command that runs, like maybe when you get where you're going to be able to see the tags, just run it for a couple of seconds just to update. But we haven't tried that yet. Something we might try to do before our next event.
So when you guys were talking about standard deviation, is that what this ambiguity threshold is?
The standard deviation goes into your pose estimator.
Okay.
So we're using the CTRE library, so it's a little bit hidden, but it's when you configure it, you set up a standard deviation, and then when you give a vision measurement, you can also change the standard deviation when you give the measurement. So we're actually just using the defaults, and it's worked well enough for us, but I've seen a lot of people discuss that on Chief Delphi, that they'll say they'll start with something higher and then scale it based on the distance or the number of tags that they can see in one camera.
So one of the things that we've been discussing potentially doing with ours is ignoring any tags that are not speaker tags. So if it's speaker 7 or 8 or 3 and 4, use them, otherwise throw them away. Just because the only thing we care about at right now is shooting at the speaker, and the speaker is sort of a fixed point. That's the point we actually care about, and we don't want the stage being pushed a certain way or the amp being pushed a certain way to change our position on the field over the course of the event. I don't know if anyone is doing that or if they have thoughts about that. We are also throwing away tags under 5 meters. I wonder if it would make sense too to throw away tags based on the velocity your drivetrain's currently running. So if you're going,
especially rotation, I've seen that too. Yep.
I wonder if it would make sense to discard tags there. I don't know. The April tag, it has some type of a like, how good is this value? Is that what the ambiguity is that says, hey, I have high confidence in this tag versus I don't?
Right. Yep.
But even when you're driving fast, you're getting back tags that have high confidence that maybe it shouldn't be that high.
The ambiguity, I believe, is mostly about it trying to figure out which direction the tag is. So if it's looking at a tag, it's hard to know if it's pointing that way or that way.
Sure.
So in our custom vision, we just send back both pose estimates, and then our pose estimator actually just chooses from the two, which is it chooses the more reasonable one. I believe Pathfinder does, or not Pathfinder, Photon does a similar thing. And another question that I kind of had was, are most teams doing latency compensation? Because we definitely are, but I can't remember if that's a Photon default thing or not.
Yeah, Photon Vision and Limelight Live now have that where it'll do that for you. Yep. Well, it gives you a timestamp, and then you plug that into the estimator.
Sam, are you willing to share your standard deviation thing with the pose estimator?
Yeah. Let me see if I can figure out how to share it quick here. Okay.
One thing while he's doing that is if you're using Photon Vision, make sure you are using multi-tag if you don't have that on. It's a setting that you have to turn on to have it run on the coprocessor, and then it's a setting in your code to say I want to do multi-tag.
Yeah,
so if you
go ahead.
Sorry, Sam. No, I'll come back to it.
Okay, and so I did like splice this out just because it looks better here. I'll see if I can make it a little bigger. And there was a bunch of like debug and junk in there, so I cleaned it up a little. But really, we're doing the always blue kind of. So our odometry, no matter if we're red or blue, is always blue. The always blue origin. Throw away null measurements. We found that it also initializes at 0, 0, and so since the robot can't be centered, it's not physically possible. We can always throw that out. And then we're actually only taking a measurement if there's 2 or more tags. And so it's actually kind of similar to what you were mentioning, Scott, where you only care about the speaker. we found that the readings from the source work pretty well too. Not that you're ever pointing at it, but if you pick it up in passing, it's not so bad. And this is kind of the squared. So really we're saying that if we're 1 meter away, trust it a lot and basically square that, square it based on distance. And if there's less than 2 tags, jump out. And then here's kind of that standard deviation of saying, make it really, really high to throw away any angle updates. So this essentially says ignore all angle updates. And then we use our new calculated standard deviations and then add the vision measurement. If you're using Limelight, the latest Limelight helpers has this timestamp seconds. So this is the latency compensation they were talking about, where it's saying, this was your position, whatever seconds in the past, 1/4 of a second in the past, 1/10 of a second, depending on your frame rate and processor. So really not, it took us a long time to get here. We tried all the velocity stuff, the rotation stuff. And honestly, this was something we could wrap our heads around and was pretty consistent. I think in teleop at a regional last weekend, I think we missed like 2 or 3 notes like the whole weekend, just kind of shooting from like the podium to under the chain range. This just worked pretty well. But we could never really get it super like crispy and precise enough to do it while driving in auto, driving as fast as we wanted to. There's just too much jitter. And if you're better at it, maybe you can get it to work, but that's kind of where we ended up anyway.
Sam, I am completely new to a lot of this. Can you explain what this vector? I assume this is Vec Builder is a vector builder. Is that what that is?
That's right.
So how does this throw away the rotation from the April tags and instead uses the odometry rotation?
Right. And so these standard deviations are saying basically the smaller the deviation, you're basically saying trust this measurement a lot. It's kind of the way the pose estimator works. Sorry, this is like a lot of math stuff, but under the hood, the way the filter's working is the smaller this number is, the standard deviation is, the more it's going to weigh this measurement. And it's really what we're saying is weigh the measurements when we're far away, very little, and when we're close, weigh them a lot versus odometry. And so basically when we give it a huge number, we're saying don't trust the angle at all, never trust it.
I see. So number 19 is line 19, which wraps to line 20. This is basically a configuration to say, consider whatever I give you at the standard deviation. Then on line 22, 23, you're actually giving it the updated pose from the April tag.
That's exactly right. Yeah.
So line 19, you're kind of reconfiguring how well to trust the pose on every single update, and then you're doing the update. Okay, right. That makes way more sense to me now that you've explained it. That's excellent. And we were trying to figure out how to basically throw away the rotation. We were trying to substitute in the rotation of the robot instead of the rotation of the tag, but this solution of just don't trust it, I really, really like this a lot better than we're not manipulating the pose that we get. Instead, we're just saying don't trust that part of it.
Yep.
Brilliant.
And this was stolen. The idea of squaring and everything, this was just taken from Mechanical Advantage. And we just kind of like Andy was saying, it's just looking at what other people with open alliance teams were doing and just picking what seemed to work for us. And this is kind of where we landed. So
yeah, Mechanical Advantage, definitely. 6328, they're the best at pose estimation, hands down. They've done more work on that than anybody else. And like half of our stuff is probably taken at least inspiration from them. Definitely check out their open lines thread.
That's excellent to know. I found a team today when I was looking at we're trying to align to the speaker, and we're over oscillating, and I'm sure it's a PID thing, but it could be a math problem too. And so I was out looking, and I ran across, I think it's 418 Purple Haze out of Texas. They have a sample archive up in their GitHub, and inside their drivetrain code, they had an aim at point, and so you could give it an XY, and it would rotate the swerve drive to point at that using a PID for. It would take in your X and Y if you're driving, but then it would use a PID for the rotation. It looked really interesting. It was a lot of math. I handed it off to my programming team. I didn't actually dig into it too much. I just said, here's a reference. But that 418 code looked really interesting. I don't know if anyone else has found some code that they like. They've either invented themselves or they found that they borrowed that aim at a target code today. I was really happy that I found that. Does anyone else have any insight in terms of swerve drive aiming at a target while you're moving?
Yeah. So like while you're moving, that's for us, we're just doing it with vector math. So the actual rotation of the robot, you're adding, I can pull up our code, but it's essentially subtracting vectors and then adding them together to get a vector to the pose that you want to aim at, and then offsetting by your velocity to figure out, you need to know how long your shot's going to take, but we just estimate that at a quarter second, I believe. I'll try and pull it up. But
Mason, are you with No Mythic? Is that right?
I'm with 2129. Ultraviolet.
Ultraviolet. Okay.
Our
the other purple team.
Yes. Let's see.
Hey, I got a beginner question. If you guys are done with your super difficult, programming questions.
Go ahead.
Okay, so
while Mason's great. Well, that'll give time for Mason to find his code.
Oh, so we have that $400 expensive camera, and we're flirting with the idea of using just for the speaker, a protect, just right around the stage, not necessarily at the stage, but just around that, by the podium area there, that line, just in case somebody decide to park themselves against the speaker, so then you don't feel completely disabled for shooting. Would you advise to pursue that, considering that our team we don't have any strong programmer on our team, and I'm constantly banging my head against the good old laptop?
My advice, like, you could do it without any estimation. If basically you tell your driver to back into the podium so they're squared up against that, you have a command in your code that turns it at a fixed angle, whatever angle that is to reach the target. If you're on blue alliance, you turn clockwise. If you're on red alliance, turn counterclockwise, or whatever it is. And from there, then you're pointing at the target. You know how far you are, and you can just have a set point there.
And I was thinking, like, maybe for somebody who is not a programmer, it's like, go early. Well, I think we should pass inspection early because it's going to be our second event. Go out there on the field and do your set point for from what angle can I shoot at from the podium, and then like you just said, because I feel that would be less complication than using a limelight, and then that fails on you, and then that creates more can of worm that I can't put back, shove them all back in there, because when those 10 minutes breaks or 15 minutes breaks, it's not much to do something that you don't know how to do.
Yeah, thanks. I think Mason's advice is really good advice, is that you have your fixed position if you're at the subwoofer, and you have a fixed position if you're at the podium. Getting this auto alignment code to work, I mean, I feel like I'm at this point a pretty veteran programmer for FIRST, and I'm walking into this code and I'm looking at what our students have done this year, and I'm lost. I really am honestly lost. And so I feel like I'm playing catch up. And if you're in a position where you don't have a programming student who's been focusing on it all year, I would take Mason's advice and set up a fixed position at podium and one for subwoofer. The other thing that you could do that would be sort of a way to nudge that is, let's say that you're in competition and you're like, I don't know what's going on, but for some reason on the red side, we're missing just a little bit high. You could put a nudge factor on Smart Dashboard so that you could enter like -2 degrees or -3 degrees, so that you could, or if you're not even using degrees, let's say you're using ticks on the built-in encoder for your motor controller. So you could nudge that down a little bit or nudge that up again a little, so that you don't have to go the whole competition missing high, or even just a match missing high. Your driver can open Smart Dashboard, put in a little nudge factor, and then you aim a little higher, aim a little lower. It might be an easy way to make something work without a ton of math and programming knowledge.
Yeah, our team, we have a nudge on the operator controller, so they can click up or down on the D-pad, and that it saves it to a network tables value. Worked great for us. For our second event, we are making it independent for Red and Blue Alliance, because we noticed at Duluth that for some reason the blue speaker was always shooting high. So whenever we were on Red Alliance, we nailed every shot. Blue Alliance, we missed most of them. So we had to manually adjust it based on the match. I have our code pulled up now for the aiming while moving. It only does the rotational aiming. So if we do like a pass in front of the speaker, it'll do that. But if we're trying to like back away from it, do a fadeaway, that's not handled in this class. So
Casey, can you make your font size bigger? You must have shared differently than what Sam and Andy shared, because I only see it on half the screen. What does everybody else see?
Oh, yeah, there we go. Okay.
Oh, better. Yeah,
Yeah.
great. And then can you make your font size a little bigger?
Sure thing. And then I'll close the stuff. Ignore the underlines. I don't know why VS Code does this, but we're starting out with a PID controller. In previous years, we've profiled PID, which that's a maximum acceleration and velocity. We didn't find that necessary this year. And this can mostly be ignored. Our constants, we're just able to change it. It's a helper class. Also, the continuous input, definitely important. We're doing everything in radians. That's hence the pi. So on execute, first it needs to figure out where the robot is. So that's just getting our estimated pose and how fast it's currently moving. From there, we actually later on, we switch our chassis speed to a translation 2D, because then you can do vector math more easily. But that has an extra caveat. Then we also have our target position. The shooter.get speaker position changes blue or red alliance, so it'll automatically reflect that. From there, also we have to know how far away we are from the target to be able to aim correctly. And so that is a get distance as a translation 2D method that you can run. Really simple to do that. The angle to the target is basically the vector or the position of the target minus the position of the robot pose. So that'll get you a vector from one to the other. Get the angle of that vector, and that's how you'd aim to the target. So basically you want that angle to be 0, and that's what the PID is doing. From here, the robot velocity, we do rotate by angle to target. And so that'll let us, I believe, yes, it rotates our velocity vector so that it's relative to the target. So if we're moving completely horizontal to it, that's what rotate by will do. It'll make it so it looks completely horizontal. But if we're like going at an angle, it's not field relative anymore. Now it's like target robot relative. Does that make sense? I hope that makes sense. So you're rotating the entire space of that vector to be relative to the speaker, and that simplifies the entire problem. Fly time is a fixed constant because the change in the note, like fly time, the amount of time that's in the air varies very little at the range where we reasonably want to be shooting on the fly. And then the miss amount is the robot velocity to get Y is completely relative to the target at this point because we've rotated it up here. And so we can basically figure out the velocity in meters per second, I believe we have it, times the number of seconds gets you the number of meters it's going to miss by.
Then and this is your, basically the Y is your left, right? So
exactly, yeah.
The miss amount is how much you have to aim behind the target.
Yeah, that the miss amount is like how much, if we do nothing, will it miss by?
Got it.
Then we can take the tangent, and it's negative because we need to rotate to compensate. You can take the take arc tangent of how much we're going to miss by how far away we are from the target to figure out what angle to rotate by, and that'll let you know how much you need to rotate. From there, it's basically actually making the robot do it. So set point angle is just wrapping it around. I believe WPLab might also have, this might be the WPLab class. No, it isn't. They might also have a wrap. That's something that you should probably write. It's like that can cause a lot of issues if you don't wrap the angles around. What that means is that if you have like 540 degrees, it'll wrap it so it's within 360. So your robot isn't doing multiple spins to get to a point, because that's obviously not optimal. And then it's also finding our current angle. From there, we can plug it into a PID controller. And we don't have it as a profiled PID, but we do have a maximum output that we're allowing it to go. That's to keep it from browning out as we're turning on low voltage. And then from there, we can get the output of the PID controller, clamp it, send it to the robot. We have our swerve drive set up with like turn requests and drive requests. This is, I believe, something that we found in the CTRE one. Basically, you can ask it to do just turn and do something, and then you can ask it just to do drive and do something, and it'll be able to do both at the same time. And that allows us to do parallel commands. So it's actually got the output and then a priority, so it can choose which one to actually ignore and which one to do.
And this is for so in teleop. So let's talk about the teleop scenario here.
Yep.
If you're using this to aim, then your code is smart enough to say just send the forward, back, left, and right joystick signals.
Exactly.
Because I'm going to get the rotational signal from this. Is that right?
Yeah. So basically, we send what the joystick is telling it to do, but with a priority of like 0, and this might have a priority of 3 or something like that.
Okay.
And so it'll take the highest priority until that command is done, and then it'll move to the next one.
Okay.
Because the command, if you're doing command-based programming, you need some sort of workaround, because otherwise, if you say this command uses the drivetrain, then you won't be able to also drive at the same time.
Cancel it.
Yeah.
That's a good point. I'm pretty sure when I was looking briefly at that Purple Haze code, the 418 code, they were also had the similar type of thing where they're sending in X, Y, and rotation, and then in their comments they said the rotation is only going to be used if the PID doesn't have a target or there's nothing specified. So that was kind of like you said, the failover. So that makes a lot of sense.
A much simpler solution that can also work is just add all of the requests together. That's what we did last year. We had autonomous driving. It's not great because if you accidentally bump the stick, it'll do all sorts of weird stuff, but it can work with very little like code infrastructure.
So are you using this aim while driving code in your autos as well?
Yes and no. So we're using this aim towards speaker. That's yes, but it is not moving while shooting.
Oh, so
we gave that a test.
Rotate in place.
Yeah, it goes to that point, rotates in place, shoots, and then moves on. And then make sure that we get a very accurate shot in auto, which is more important than doing it quicker, we found, because 5 points is more than 0. But also that gave us the opportunity to basically ignore April tags until we're at a point where we're about to shoot, because then we're sitting still and it's using the April tags to aim towards the speaker. So we can choose when to ignore them, when to use them based on when we're shooting.
Yeah, that's smart. I like the idea of not trying to use April tags unless you're standing still, so you get a nice clear image.
Another thing, it's not in this class, that helped us a lot with odometry actually was finding the exact radius of the wheel. The way that we do that, we have a command that it's basically bound to a shuffle or a smart dashboard value. You set it to true, and during that period, it'll collect it. You spin the robot in place, and using the gyroscope, we can figure out how far it's moved, and then how far each wheel is moved. And from there, you can do some math stuff and figure out how big your wheels are. We pretty much took this exactly from Mechanical Advantage, but made it so that it doesn't automatically drive. We just drive in place.
Wow.
And this code, I can't honestly explain it because it's like half Mechanical Advantage and half the other programmer on my team. But it has worked really nicely. So now we can follow paths, even really long ones, and it's able to get the wheel radius. I don't know how accurately, but it gets it to like the 1,000th of an inch. And from that, we have much more accurate odometry, and it's much easier to calculate because like before we would just push the robot and see how far it moved. But now we can run a command while it's on and enabled and just spin it in place for a little bit, turn it off, and it'll print out what the actual wheel radius is.
That's awesome. That's so awesome. I learned a ton. Thank you so much.
Yeah, I was going to comment on your shoot while move. I like the use of the constant to estimate the time. A lot of people get hung up. Like we've had multiple kids that are interested in it, and then they really get hung up on, well, how long is it going to be in the air? We have to know how
Yeah.
long it's moving and
I'll
do
actually,
physics. And then it's like, well, there's also aerodynamics, and the thing might be flying a little crooked. It's
I'll
good
share
enough
my
for FRC to estimate it that way. I think that's great.
I'll share my screen again. We also have much more intelligent lobbing, because at that point, that's essentially it's when we go to midfield, shoot it over the stage, and then dunk it over by the amp so we can use it later. The note, that is. But for that, we did need to do much more complicated math. So that was my introduction to calculus. But I can pull that up really quickly, and that actually compensates both for like forward, backward, and side to side. And that allows us to lob a lot more accurately. So it's pretty much the same command as earlier with the aim towards the speaker. However, we do actually calculate the amount of time it's going to be in the air. This is more complicated since last time I saw it, but we do calculate how far it's going to be in the air using some physics calculations. And so this a lot just comes down to, it's, I don't know how to explain it. You kind of have to work out the physics yourself, but it does help a lot. So our lobbing, the angle is calculated by a physics model, but the power, we take the output from the physics model and then just multiply it by a coefficient to get how fast to actually shoot it. Because trying to calculate like grip on the note is just ridiculous. I know like 3015 has done that, but we don't have that kind of skill. And so we can get an accurate amount of time that's going to fly and then account for that both in the rotation of the robot and the angle of the shooter and power. So it'll land in the same spot every time. And this is one of those things where we tested a lot in our simulator before putting it on a robot, but it's been working pretty good. And this is our workaround. We found that adding spin to our shooter actually made the lobs much less accurate, because we found this bizarre behavior where if we were lobbing on the red side, it would lob outside of the field. If we were lobbing on the blue side, it would like hit the speaker. That's because when we shot it with spin, it would actually curve, or maybe it shot out at an angle relative to the robot, and so we have to correct for that.
It's amazing. This is fantastic. I am out of questions. That was amazing. Does anyone else have any other questions on April tags or autos or aiming while you're driving? Anything else anybody wants to chat about tonight? I mean, I have some other things that I can bring up, but they're not questions I have. So does anyone have coding questions that they're hoping to get some help on?
I have an easy one.
Go ahead.
So, since what is the latency when you have to use your limelight to give a feedback to the driver station just for vision? Like, because my kid is struggling trying to, see the note when the robot is facing away from him. So if we could use our limelight for just knowing what that note is laying, what is the anyone use it for just vision, and is the latency period so bad that you shouldn't even use it?
I would say the latency is pretty like nauseating almost. It's not great, but one thing that can help is if you're going to use the limelight, have a button on your controller that makes your robot do robot relative drive as opposed to field relative if you're swerve. Okay. Because then you can hold down that button, look at the limelight, and then forward is forward to the limelight. And so you're driving relative to the limelight. That'll help a lot, because otherwise it's really trippy.
All right. Thanks.
Yeah, that is a great suggestion. I had never even considered that. We don't have a driver camera this year, but switching to field relative versus or robot relative versus field relative with a button is an awesome tip.
Oh yeah, also if you're only using it as a driver camera, lower the quality to garbage and beyond garbage, actually, because if you're just seeing an orange speck, that's good enough to drive off of. Your latency is going to be better, and it's much more it doesn't really make you sick then.
Yeah, we've been running 18 by 30 pixels, and that's been the best for us.
Yeah, really, really, really bad really low resolution will get you the fastest latencies.
All right, so I've got a question. We've been using Path Planner in our auto. That's how we build it. We have a 4-note that just starts in the center of the subwoofer and then grabs each one of the notes from that first row there and goes back. We've wanted to try some stuff with rotation, but anytime we've tried to rotate, it will not do it. It'll do kind of whatever it feels like. I haven't tried like seeing what like printing out what our rotation is from we use a pigeon for our gyro. I haven't tried like printing out and seeing what it's seeing. Is there a reason that our pigeon isn't very centered in our robot? Would that cause that issue? Maybe.
It shouldn't. Is it flat?
Yep, it's flat.
Okay, it's probably more like a PID tuning thing with your angle turning.
Okay.
It's either that, or it could also be that your gyro is 180 degrees off or something like that, or it's 90 degrees and you just need to offset for that.
Okay, I'll look into printing out those values and seeing if I can kind of diagnose that a little more. But thank you.
Riley, are you using April tags for your position, or is it pure odometry?
Nope, it is pure. I just give the X and Y into the Path Planner and take it out. We are going to look into that a little bit in the off season, but we're very simple in our coding.
Are you using Advantage Scope?
Say that again.
Are you using Advantage Scope?
No.
So my advice to you is that make sure your robot knows where it's at first. So we ran into this problem ourselves when we first started trying to do autos, where we got swerve to work so that the driver could make the robot move where he wanted it to move. But the problem is we had all these things inverted the wrong way, and then Path Planner was not able to make the robot go where it wanted to go because the robot in reality didn't know where it was. And so when we brought it up in Advantage Scope and we were driving it and we were turning it, it was not on the field. It was not moving on the field the way that in Advantage Scope, the way that it was physically moving. And that's how we discovered we had all these things inverted. And so the Advantage Scope will show, using the odometry on the robot, it'll show you where you're driving on the field. And so you need to make sure that when the robot moves in reality and physically moves, that matches what it's doing in Advantage Scope. And if those two things don't match, then your robot doesn't know where it really is, and so you're not going to be able to get it to drive a path.
Okay, Advantage Scope
it's like a logging debug tool. Does anybody have it on their laptop that they can bring up? And I mean, without a robot, you can't. There's a lot of things you can't show. But does anybody have the ability to kind of give it?
I have it open. I was just playing with it. It's pre-installed this year with WPI Live, so it's already there. So I opened up a log from one of our matches, and I was driving the robot around, or I was showing it, but now I got it funny here. Let's see. There we go. So this is one of our elimination matches. It recorded the log on the Robo Rio, and I can pull up the data that it would be sending over the network tables, and you can play it back in Advantage Scope and see that it's moving around. So I was looking at this compared to the video, and in the video of the match, the robot stops way shorter than what it thought it was doing. It's also really helpful if you connect Path Planner with its telemetry tab when you're running and see what Path Planner thinks the robot is doing. I would start with this, look at where your robot thinks it is on the field, but then it's interesting to see where Path Planner thinks it is, because sometimes it'll be be telling it to rotate to the right and it's rotating it to the left, or you think you're starting at one spot on the field and you're really starting in a different spot. But Advantage Scope, you can connect it to your network tables, and then all of your data that you're sending over will show up over here. So this is a logged version, but my photon vision data and everything is here.
The other bare bones approach is the field 2D object in WPI Lib. will let you view it in glass and shuffleboard and advantage scope. You can view it anywhere. Although I think it is a little more performance overhead. My other advice, if it's not working, set your PID values all to 0 and figure out if the robot is doing what a Pathfinder is telling it to. By setting them all to 0, it's basically just completely open loop. That's what we actually accidentally ran all of our autos last year with, and it was surprisingly accurate. It can work, especially if you're only going for the short notes and the rotation isn't working. Set all of your KP, KI, KD to 0, see what it does.
All right, thank you guys. We'll definitely look into the advantage scope, and I'll give that a try and see where that goes from there. But thank you very much.
Yeah, this odometry window is very similar to the field 2D that you see. It uses the same data, and it like draws a line where you're driving to, but it's the same data that you can see that way.
Yeah, this view that you're showing right now, Andy, this is how we discovered that we had all these inversions in our swerve drive, because we were spending all this time trying to figure out why isn't auto driving the path. And then we were like, wait a minute, does the robot even know where it's really going? And then you bring this up and it's obvious that, okay, we've got a problem here. It's pointing the wrong direction than where it's actually going. So this is it has been a great debugging tool.
And this is interesting to watch after talking about April tags too, because there's this spot like right here where it jitters. That probably wasn't the driver doing that. That was probably April tags adjusting it by a distance.
Andrew, out of curiosity, does your team use OnShape?
Yeah. Yep. That's how we got
I've been trying to get
in here.
Yep. I've been trying to get a robot model uploaded into Advantage Scope for literally 6 months now, and I cannot get it. I'm trying to take it from SolidWorks, plug it into a conversion tool to get it to JIT-F, and it does not want to use it.
I followed their steps that they had on the website. And
I think the only way now is just for us to upload our robot model into OnShape and export it from there. It's kind of crazy.
Good stuff. Great question too. Anyone else have any things that they're struggling with or want some help with, or just general, just even process questions? I had on my topic list because I thought this was pretty relevant, especially for new programmers. We didn't do a great job this year. Well, maybe we did, and maybe it just there was so much information our students it fell out of their brain with all the other things because we just overwhelmed them with information. But I think it's really cool when students learn about the different parallel groups. So the parallel command group for autos, you can put things in, you put commands in, so you can say run my intake, run my index, or run my shooter. And in theory, the note will just go right through your robot, assuming you don't have a handoff. But then what happens if your intake doesn't have an end, right? Because your intake is not done unless somebody let goes of the button, and that's not going to really work in auto. If you put them all in a parallel group, that parallel group's never going to finish because your intake and maybe your indexer, of course, I guess if you had a sensor in your indexer, the indexers could say, I'm done, the note's gone, I don't have anything else to do anymore. But in theory, your shooter and your intake would have no end. It would never know when it's done. And so that was a question that came up with our programmers this year. And so we taught them about race groups and deadline groups. And so for those of you who this is new to you, there's a couple of distinctions. If you put commands in a parallel group, those things will run in parallel, which is why it has that name. And the group will only finish once everything in that group has finished. And that's never going to work for something like an intake group because the intake never knows when it's done. So what you could do is you could, on just your intake, you could take that intake and stick that inside of a parallel deadline group, and then have in a parallel deadline group, let's say that you had a wait command that waited for 3 seconds, and then as your first command, and then your second command was run the intake, which would literally run forever. And in a deadline group, it stops when the first thing finishes. And so you might have a wait command and it's running for 3 seconds, running in parallel with your intake running all the time. And so as soon as the first thing finishes, which is 3 seconds, then the next thing would finish. And so you can use a parallel deadline group. You could do it with a timer, but you could do something else where maybe you've got a sensor that says, hey, the note's finished, it's gone. And so now that the note's gone, I can stop my shooter and my group can finish. So that's something that was new to a few of our students, is this concept of a deadline group where the very first thing in the command determines when everything in the group is finished. Another thing that we ran into was a race group where you might want to run 2 or 3 things in parallel, and as soon as any of them decide that they're done, they've completed their task, then the rest of them finish. And so the race group is the first one that's done of any of them. And so that can be a very handy way to design your command groups. And something that we hit on Friday, that I think Fomia, it was new to her, or maybe it was an accident that we didn't realize we were using the wrong command, but we had changed our auto to do something else, and it started crashing. You'd start the auto and immediately crash. Start the auto and immediately crash. And the error was that there was an error in building the auto. And what it was, and I had a feeling what it was, and it turns out that's what it was right from the start, was that you were using 2 commands that had the same subsystem requirement. So 2 commands that we're trying to run in parallel. We're trying to use the indexer, and in a parallel group, all of your commands have to have the requires tag, use different subsystems. So you can't have 2 things running in parallel trying to fight for the same subsystem.
Yeah, after that, we kind of started trying to separate all of the commands that we wanted to run so that each of them just used a subsystem that they needed and they weren't trying to overlap and fight over each other.
Yeah. So I think everyone on the call tonight, you guys are all very well versed in this, but we have a lot of people that watch this on the replay as well. So there are several teams who are competing in week 4 and week 5, and they're racing to try to get their autos done. And in the event that anyone else is out there just saying, how do we do things at the same time, or we need to know when something is done, do a little research on these 3 different parallel groups. Figure out how you can nest a sequential group inside of a parallel group to do things in order. And then, like Afomia just said, we started looking at, hey, we've got this pickup command that runs our intake and our indexer at the same time. Maybe for autonomous, we have to break those into 2 separate commands, because in auto, we want to control those independently inside of a parallel group, where that's not something we need to worry about in teleapp when it's responding to someone holding a button and then letting it go. So I thought that was a really good tip. And knowing how many people watch us on replay, even though the folks on the call tonight seem to be really expert, I wanted to make sure we brought that up, because those grouping of commands, if you're new to autos, it can be a tricky thing to get your head wrapped around.
Yeah, and I just want to add that it's not only helpful if your commands don't really have an end that you're trying to like make an end within your auto. We ran into a problem where our intake or index command, it's supposed to stop when the note is detected, but when we were testing at some point, I think this was before Duluth, but we were supposed to have intake in the note, and then it would stop that and continue to the rest of the path, because at that point we had already driven to the note that we wanted to intake, and then we were trying to intake, and it just stopped there because if we didn't intake properly, and the intake command never ended. So even though we were at the end of that path and we were already sitting there for a good 10 seconds trying to intake, because it didn't detect the note, the command wasn't over and we never moved on to the rest of the auto. And that kind of wasted time because we could have moved anyway. So then I think that's when, I think it was Scott, but we came up with the idea of doing a deadline for intaking and indexing with a wait command, so that we're not sitting anywhere trying to intake or index for more than, I think it's 3 seconds now. So that doesn't mess us up and ruin the rest of the auto, when really we could just move on. Or even if somebody else actually picked up that note during like an auto, maybe they got to that note before you did, and you don't want to be stuck there because your command is like, I don't have a note to pick up, and it just stops there.
Yeah, it's really neat when you start looking into all the different ways you can nest these commands and put them in with the wait command as well to delay something ahead of time and then start going. Command-based programming is super powerful when you start putting them into auto commands in these command groups. It can really do a lot. It can be mean, that almost could be a session for us for a whole night to put together example commands and how you would stitch them together into a complicated auto. Lots of comments. What are the folks saying in the comments here? Sam, you said you ran in the same thing, forced a bunch of refactoring. I'm assuming you're talking about the requirements, the required subsystems.
Cryptic error too, a little bit.
Yeah, it's not super intuitive.
And then
but
the same
usually,
thing with
I would say that most of the time when I've seen our autos instantly crash, it's because you've got two commands that are trying to run in parallel. And a lot of times it's the type of thing where, oh, wait a minute, we don't have to run these sequentially. We could run this at the same time. And then you put them in the same parallel group and then suddenly it's crashing. And you're like, wait, I didn't change anything. And then you realize that you're fighting for the subsystem. And unfortunately, it's a cryptic error and it's just an instant crash and it doesn't even try to move. So that's a good tip for everyone. Oh, Mason, I'm glad you brought that up. I was thinking about that as I was talking, and I totally forgot about that. But now all commands have the ability to, what is this called? Fluent? Is this called fluent programming when you can do a dot on the end? And so you can add a timeout to your commands so that they automatically cancel after a certain amount of time. So to Aphomia's point of, hey, if I haven't picked this node up by the time I've gotten to the end of my path, just I'll give it one more second and then time out and then continue the rest of my commands. Because you may actually have it, but your sensor may just not know it because it got kind of stuck in the back or something. That's a great tip. Thanks, Mason.
I had another question, a couple other questions. The first one is, how are teams shooting well from the amp zone? For us, we found that it's at an angle, and we hit our shots everywhere else, but from there or at other like steep angles, it'll always shoot lower. Does anybody have a solution for that?
I have a thought, but I haven't tested it yet. And actually, I was going to bring this up too. Are you considering the speaker at 0? Like the blue side, it's the Y, the X is 0. It's right on the wall.
I think we might be right now. Yeah.
Because I had an idea that I was talking to my programmers of, instead of aiming for the XY, assuming that you're aiming for the center of the wall of the speaker, what if you brought that X out 12 inches and you were actually aiming 12 inches out from the wall? Because then you'd have a little bit of a backboard on the side. If you're shooting from the side, you'd have a little bit of a backboard as well, and the opening might be a little bit bigger. We talked about that in Duluth when we were trying to tune these autos, on the practice field in Duluth, and then we just completely forgot about it until tonight. But I'm interested to test for us if, rather than setting our speaker point to 0 and whatever that is, like 4.3 meters or something like that, if it was actually 0.25 or 0.3 meters, and then your Y value, if you'd have better luck when you're shooting from the side, because it really shouldn't change anything when you're shooting straight ahead. At least it shouldn't change much, but it would potentially make a big difference when you're shooting from the side.
Yeah.
Does anyone else have any thoughts on that? I'm also considering taking, sort of the angle of how far to the side are you, and then having to adjust by a variable degree angle depending on how far you are in an angle. We're not even there yet. We got to be able to we have to do a better job of making it, within a reasonable arc before we start to do too much on the side.
One of the solutions that I've seen was the mechanical advantage. They have 3 different points they aim at. So they have like the 2 corners of the outside part of the speaker, and they have the center of it, and they aim at the closest one. Which I think is a lot what you're talking about, but it'll even aim like towards the corner of it, so it really gets in more often. We might look into that. The other question that I had is, we were kind of running into a little problem with our, we have a really fast robot. We're running L3 plus the upgrade kit, and the controllability is getting really interesting. Like, how do most teams do that? Do they have like a fast mode button? Is it just hope for the best?
On our robot, at least, we have a toggle on like the left joystick where he can slow it down to about 1/3 of its normal speed. And rotation is completely automated. We don't even bother with doing it manually, more or less. We have a button that goes to the nearest, I guess, compass heading.
Yep.
And then we have buttons that go to our scoring angles for like the amp or the podium and whatever.
Yeah, something that we've messed around with a lot was the actual like mathematical trajectory sort of the joystick. So like 2 years ago we had linear, so it'd be like if you push it to 1, it's at 1. If you push it to 0.5, it's at 0.5. Last year we did quadratic, and so that helps a little bit with control at the low end of the stick. But this year we're trying out like we tried out cubic, and now I think we've settled on like to the power of 2.5, and that feels pretty good. But also, like we've also tried like a slow mode button, a fast mode button. Fast mode is just like we just want it always fast mode because then we can just go faster. So we've removed that, but now it's getting hard to control again. So
I mean, on our team, I don't know if you're already doing fancy dead zone math, but we moved away from like squaring or cubing it or whatever, and we're just doing a bump up. So like, say the first 5% of the joystick does nothing, and then 6% jumps it up to like 15%, because that's when our motors start actually moving the robot.
that's a good point, because we actually have the opposite. It'll go like, first 2 or 3% is dead zone, and then if you push it to 4%, that's actually 0. So it'll remap it 0 to 1 for the effective range of the joystick. Because we found like, especially with really bad joysticks, if you have a large dead zone like 8%, you push it to there and suddenly the robot gets really jerky when you try and stop it. But that might actually be a good point, is figuring out how fast do you need to push it to make it move at all.
Yeah, I like that idea of setting your bottom to the effective power to make your robot move rather than setting it to 0. That's a good idea. I have a question. We only have about 10 minutes left here. One of the things that I've been thinking about for years, actually, putting together for our team is sort of how to use Git for FRC. There's a lot of things that you can do in Git, and it gets complicated when you start digging into Git training, but there's kind of 8 or so things that you actually do on a robotics team. Do we feel like having a Git session would be good? I actually feel like it might even be better as a recorded training video. I don't know how well that's going to work in a format where you can't have a couple of different computers and people pushing at different times and trying to do merging. So I was trying to think if I was going to do that tonight, if we ran out of stuff to talk about, which I'm very happy we didn't. I was trying to figure out how to do a little demo on that, but I'd really love to have some feedback on what people think would work the best. Does anybody have any Git training they do for their team that they love?
Not nothing we love, I guess. we bare minimum to, I mean, we really simple, just a couple of branches and otherwise push to main, basically. I mean, a branch if it's experimental and then we review it. Yeah, I don't have anything great, I guess.
We started doing something this year that I really like. In previous years, and I'm sure other teams have had the same thing, where you've got a branch called John and a branch called Nicole, and the branch doesn't actually tell you anything about what's on that branch, just who owns it. And this year, Afomia and Caleb, and I think the other students are doing it too, but I've only been paying attention to Afomia and Caleb's branch most recently here as I'm starting to get into the code. They're using the slash, which it's just a character as far as Git's concerned, but a lot of Git tools will put that into a folder. And so the students have been using their initials slash and then what they're working on. So you can not only see what's the feature that branch is being worked on, whether it's autos or it's aiming or whatever it might be, LEDs, but you can also see who owns it, so that the students can they can sort of have their own folder of the branches that they've been working on, especially if they're doing kind of prototyping type stuff and it may not be code that ever makes it into the main branch. But I really like that. That's a strategy a lot of companies use, but I think this is the first year we used it on the team, and it wasn't even my suggestion. I don't know if Brian brought that up. Aphonia, do you know who
Yeah,
came up with that?
Brian did
Brian
kind
came
of
up
bring
with
it
that.
up. I'm not sure how many of us are actually using it, but it seems like a lot of us. Like you said, from what I've seen of me and Caleb's code when we pulled it up yesterday, actually, it organizes it really nicely into folders, especially because some of us have a tendency to make a lot of branches. So whenever we do we've started doing just our initials and then a slash, like mine would be AM slash whatever it is, like aim while shooting or whatever it is I'm doing on that branch. And when you open up like TortoiseGit or whatever you're using to look at your branches and everything all together. Scott, what was the new one that we were looking at yesterday?
Get extensions.
Yeah, we installed that on a laptop and it organized it really nicely into folders. So I think that's something a lot of people should maybe look into.
Yeah, I think at some point it would be nice to do some Git training. I feel like too many of our students are relying on Visual Studio to do its magic with Git, and they don't really understand the concept of fetch and pull and push. And I committed my code, but it's not in GitHub and those types of things. And then there's of course pull requests, which we do really well for our website. Our website is using GitHub Pages, and so nothing hits the website unless it gets on a pull request. But a lot of our code is merged branch to branch, and that's often how it makes it to main or how feature branches get pulled together rather than doing pull requests in. And I think that's okay, but I think it could be some good discussion of when do we just merge and when do we do pull requests and what's our process there. Like I said, I feel like that actually could be a multi-part piece of training, and I'm struggling with the correct way to present that. Whether we would want to do that sort of in a live video where we can have Q&A, or if it makes more sense to scan a scenario and then walk through a full-blown scenario with multiple computers doing pushes and merge conflicts and all of those things.
I feel like you could do kind of at the beginning a lesson of like the main things that you feel like everybody should know regardless, and then walking through a made-up scenario so that people can ask questions along the way and you can answer them with actual examples and like physically showing it instead of trying to explain, because it's pretty hard to explain when you're not looking at it something.
Right. I'm curious, what is everybody using for Git tools? Are you purely Visual Studio, or are you using command line, or do you have another Git tool that you love?
I use GitHub Desktop, but the other programmer on my team uses the command line. Works out well.
Our team is full command line. I mean, we have trouble with merging on anything but command line. So
yeah, GitHub Desktop here.
We use a lot of everybody has their favorite, and personally, I use 3 different Git tools for my job. I use Git command line for the things that are cloning a branch and things like that, or doing a reset, Git reset -- hard type thing. If you have to do that, there are a few things I like in the command line. I think TortoiseGit has got the best merge conflict resolution tool. I think Git extensions got the best sort of branch visualization tool. So I use a lot, and Afomia is just recently getting into what are all these things. And then of course, Afomia is working on a Mac, so we have to get her source tree and teach her how to use source tree if she wants a visualization tool. So I think that there's some really interesting things and topics to be discussed about Git, because it's important to use source control, but it's even more important to know how to avoid trouble or to get yourself out of trouble, because you're always going to get in trouble at some point. Something's going to happen, and it's good to know how to use all the different tools. Well, I tell you, I thought this was a great talk. I came in with almost no expectation or preparation, and I put out some bullet points, which we barely even touched on. Thank you so much to everybody who showed code. That's so awesome and great advice. I feel like I learned more in this call than any call we've had in quite some time. So I appreciate you guys sharing your knowledge with KnightKrawler. Afomia and I are going to have a lot of things to look at now on Monday, Tuesday, Wednesday this week. So we appreciate it. Anybody have anything else? I will say that so Michael Flood was going to give a talk next Sunday Turns out Sunday's Easter. I don't know how many people have plans with family on Easter, but Michael and I agreed we're not going to do a call next week because people might be out of town or we just don't know. So we're going to move Michael's talk to the Sunday after 10K. And
I think I'll get killed if I log into this.
Right. Yeah, I think the people that are on the call that are married, they might suffer the worst from attending a Sunday night call on Easter. Oh, I was going to do this earlier and I totally forgot. In the last few minutes, Sam, you guys competed in Iowa, is that right? Did anybody else compete in the last week? How did things go? Tell us about it.
Iowa's interesting. The teams were really good. It was a very competitive event. There's a lot of I don't know if you're used to kind of doing like the Duluth, Great Northern, whatever circuit. It was fun to see a lot of out-of-state teams. So like Stealth Panther was there out of their Missouri team from Brazil, 1156. Really, really good. Yeah, and I mean, in the end, Becker ended up taking the whole thing with Mars Wars, which is it was fun to see their alliance, how strong it was, and just seeing how far the game's progressed since week one. I don't know. That's kind of highlight. I was surprised how like deep the event is and how good teams are getting. Just in the playoffs, it seemed like kind of table stakes was scoring a couple from the middle in auto, which was interesting. I mean, we all knew it was coming, but it's kind of now.
I did have a question on some of the tournaments. Seems like defense has been a big thing in a lot of tournaments. But then, so I was watching the one in Colorado yesterday or last weekend, and there was no defense at all in the playoffs, which sort of surprised me. What's people's thoughts as to what they expect 10K and future ones?
So when we were in GNR, that was supposed to be our strategy primarily if our robot had done what it was supposed to do. But you're right. There have been times where I've seen very little defense in this game, and there was this one robot with the kiddie pool that did an amazing job of that. But then I was watching in northern New York, Albany, their regional, and there was this other robot that did like a shower curtain type thing, and there was, but there are these other teams that just go out of the play defense entirely. Like this one other robot, I think it's 229 out of Potsdam, New York, where all they had was a base, and the whole strategy was just disrupt the any shooting pattern. But what I also saw too with those teams, like the Sub-Zero 229, they never really went further with that strategy. So I don't know if sometimes if you don't have when you have a mechanism, I'm thinking maybe like I was telling my kids, okay, if we want to be primarily on M-bots, go to the source, but go by their source so you can disrupt that pattern while you go to our source to pick up and then come back and deposit it in the amplifier. So doing that is like playing a little bit of both worlds where you're still playing defense, but at the same time telling the other people like, hey, I have another thing, in case you need me just to be a support amplifier in a robot. I don't know, but what I'm seeing is just all over the place.
I've noticed that it depends a lot on region. Like if you look at like Texas, there's a ton of defense, and then you look at other districts especially, and there's almost none. I think it depends a lot on like the distribution of teams. The events that I've been watching where there's a lot of defense, it tends to be like number 1 and number 2 seed are the expected winners, and everybody else is just trying to defend them. I wouldn't really expect to see that at 10K or really any FUM events. It's I think too competitive of a field to really have that kind of strategy pop up where you have like even 2 defense bots. I would say we should hope that there's very little defense.
I think there's an interesting. Oh, go ahead.
I was gonna say we actually brought a shot blocker kit. Like we built one on a practice bot, and we brought a kit to pop it up if we ever needed to. Some PVC and a tarp, basically. And we ended up not running it just because kind of landed on you need 1 or 2 bots with a ton of firepower, and if your third one doesn't, it's time to run defense. But even if they're making 4 or 5 in the speaker at all, and you're maximizing amplification, it's kind of hard to pull them off. I mean, if they're not making those 4 or 5, I don't know. There was no defense in Iowa, basically. I was kind of surprised to see it, but also it really depends on who you're playing too. I think in Duluth, we learned a lot of lessons about if you're playing against a lot of subwoofer bots, it's probably not, don't let them triple offense you. It's not good. They will bury you. They can score so fast and line up so fast. And you can maybe even have their cycles with some defense. But if someone, some of the ones that can shoot from the podium really well, or they can shoot over you, maybe not as strong. The game's still developing, but it kind of depends on the depth of your event too, just what you can get for that third robot. Yeah, I think especially like your Lions 7, 8, 6, 7, 8, where you're going to be 3, maybe not powerhouses, but 3 good shooters, maybe not worth it. But for Lions 1, 2, better shot. I don't know. That's what we were thinking. Didn't come into play, but it was on the table.
Yeah, I was going to say that I think it really depends who you're up against. If you've got 2 subwoofer bots, I think a defensive bot has strategic implications there. Mm-hmm. If everybody's kind of a shoot from anywhere, that gets a little bit trickier. I'm very interested to see in these remaining weeks, and as we see champs come in, if we're going to see defensive bots that shoot across the field, that can opportunistically pick up a note, drive out to the wing line, get it over, shoot it across the field, and get it ready for your friends. I wonder if that's going to start to evolve as a strategy where you've got a defensive bot who's picking up notes as they can and then sneaking out to the wing line whenever they can to fire it across the field. But yeah, if you're up against the 3 powerhouse robots that can score from anywhere, defense gets a lot harder.
I think a lot of teams should practice with a defense bot. It's a fun project for bored people too. If you have an extra drive base, another drive in a day, whatever it's called now, have them assemble something and have your drive team practice against that, because it is not an impossible challenge to overcome, a wall sitting in front of the speaker, but you have to know how to.
Yep.
And just also the game is getting very rough. I mean, it's just a very aggressive game. Against us, Becker was given a red card for basically just being a bowling ball, essentially. And I mean, it was against us, our alliance, and we had a really hard call to make, whether we replay the match or accept it or decline it. And I think there's kind of a gray area now from ref to ref of what is considered too aggressive. It's kind of a hard, and they weren't doing anything intentional. They're just playing the game, driving fast, trying to pick up fast. But when you're max weight and you're hitting people, it's damaging. I mean, 20 feet per second. And so it's going to be interesting to see how events are calling that, whether is a head-on max speed collision, is that a red card? Is that a yellow card? Does it depend on if the robot's made well or not? I mean, kind of arbitrary. And so it was hard to see that happen right in front of us, just to know, is this right? Is this wrong? What does the manual say? It says it's gray, and
right.
And ultimately the card comes out, and what do is it, what are you going to do about it? And so be prepared to make those calls too,
So Sam, was that, I heard one of the robots, was that you guys that had your mechanism broke or something?
Oh yeah, our arm fell off. Yeah, our arm fell off. Yeah.
It was your arm, and it was the impact that got the red card, is when you lost your arm or something like that?
I actually don't think it was us. 525 lost their bumper.
Oh, okay.
I guess I honestly, by the end, all 3 of our robots were basically disabled. So it was, we were playing defense. It was fine. And I mean, honestly, I think our biggest struggle with it was if you had asked us, name 3 parts of the robot that are going to break, we would have named one of those things that broke. And it's just kind of it's partially on us. We knew the game would be rough, but also, what isn't it reasonable to expect? Is the max speed, max weight collisions? Is that the expectation or not, basically?
Yeah, I have experienced this.
Max weight. Our robot was max weight too, and it is unbelievable how beat up it was. We even found part of the frame was bent, and every mechanism was beat up and bent. So yeah, build your robot sturdy this year for sure.
Isn't that kind of late, Andy, to give that kind of advice? Come on.
They basically had to strip it down and rebuild it for the next event because everything was bent. Every single piece was
we
bent.
did the same thing, and I've expressed this opinion to several people. Is I'm very nervous about how we're going to do a turnaround between 10K and champs, and then between champs and state, because we have done nothing but rebuild the robot the last 2 weeks, and so we just started running code, trying to do our autos again middle of the week last week. Now we did have spring break in there, but we still met a lot of spring break. I'm very nervous about the turnaround time with so much damage. I mean, we pulled it all the way down to the frame, and more than half of the robot is new.
Hey, I got a question here. Speaking of robot redesign and rebuild, so with this Quaco intake shooter mechanism, so and with all this, it's easy to take impact with that, with that mechanism. Now, if you made a rectangular, and this is gonna sound stupid because I don't know much about swerve, um, will you advise a rectangular robot with swerve modules?
As opposed to a square?
Yeah.
Oh, ours is not a square this year. I mean, it's not a rectangle by much. It's only 1 or 2 inches.
Because we were thinking if we added, 8 inches in one direction, more it would still meet the parameter, 120 inch, and then drop that whole mechanism on the inside, so you can pick up, on the belly, intake by default, and then when someone hits you, they hit your bumper. They're not hitting your main mechanism, and that's kind of a quick overhaul that I'm seeing, or for the time frame we have that can be done, because all we got to do is just remove those two long pieces, and then even though our belly pan will be a little shorter on the front, but we don't need that because then that gap is used for for the intake.
Jeremiah, you should look at 3883 data bits. They have exactly what you're talking about.
What did you? What is it? What is it, Mason?
I believe it's 3883 data bits. They have
Data
that
bits.
design where it's got an arm that goes inside the bumper. I believe it held up pretty well.
Because I mean, the thing is, I'm not even more worried about other people. I'm more worried about my kids. GNR, everything hit that stage so many times. We had to rebuild. We had to rebuild our main mechanism. All those aluminum, we had to use a thicker walled aluminum because they were all twisted. The shaft, steel shaft, they were all bent. That was just damage from my own kids slamming our robot for not having driver practice. Now that we have some driver practice and the game is getting to this point where I can see a little bit more aggression in some of the areas too. I just don't want us, now that we're having some fun with our robot, I just don't want it to bring it to a point where it's like for the kid to have fun and suddenly bam bam, and then you find yourself a competition doing a big major fix that you probably avoided if you thought about something else. That's kind of why I'm flirting with that idea to put it to them this week.
Another thing that I've been thinking about with the arm robots is the gussets that hold your intake onto those big arm tubes that go to the pivot joint. Make those gussets like intentionally weak, because then if you take a really bad hit, it'll mangle those gussets, but hopefully it saves the rest of your robot. That's something you can machine 8 spares of. You replace those every time they get bent, and then you don't have to worry about like your pivot mechanism breaking, because that's the really dangerous bit that I see. I mean, the intake you can also make a spare of. I'd probably do that.
And we're doing that too. I told him to us because we had it made. Just have a spare, made it with the right wheels. Just all we have to do is just remove it and slap the other one on, and then connect it, the wires, and that's it. So hopefully that works out. But it's like herding cats with my kids, so I don't know how. Especially over spring break.
It sounds like a big job, honestly, Jeremiah. But I can't say enough about intaking inside the frame perimeter this year. Not going outside with all the damage that we've had. I'm so glad we decided to do that. I mean, we're totally beat up as it is. I know that last week John was saying that Robettes, sorry. The Robettes, their robot was physically broken in half. The left side and the right side frame was completely broken, and it was the frame was in two pieces. Technocrats up in Duluth, they had a piece that completely cracked and broke on one side of the robot. It's just a lot of high collisions. We added a lot of reinforcing to our frame, and made things a lot, we hope, sturdier. I'm still anticipating we're going to have to replace a ton of parts after our next event, and especially after champs. So yeah, I'm very nervous about it, honestly, that the robot may be so damaged that it's going to be too many hours to get things back in working order.
The other one that was interesting was at Iowa, they had the driver station and the walls like ratchet strapped together. I hadn't seen that ever before. Kind of hard to describe, like where the source meets the driver stations, that kind of, there was a ratchet strap that ran around everything so that you couldn't open up a gap from hitting the wall so hard on pickup. That seemed to help some, but that driver station right by the source, so 525 again, they had full Velcro on the bottom of their station. It still flew off, and lost cables and everything. And it's even their one driver, the thing hit her so hard it bruised her in the hip, and it's kind of like, what, I don't know. It's kind of, she was trying to maybe even hold it on with her hip a little bit just to give it that extra catch, but it was too much. And so it's brutal out there. I don't know. We'll see what they do, if there's any changes or anything. Right or wrong or whatever, that's what's happening. So
I wonder, we forgot to put Velcro on the bottom of our new driver station in Duluth, and our driver's holding it on with his hip. And then after our first match, we went and did that. But maybe we need to look at doing a bungee cord to attach it to the driver station somehow or something for these types of things. I hadn't even considered that, but yeah, it's a rough game. It really is a rough game. Maybe we need to, on the bus ride back from champs, we need to put the robot on the bus and have the kids rebuild it on that 26-hour bus ride back on Houston. We'll see. All right. Anyway, thank you so much. I know that we went really late tonight, but it was such a great discussion. I really, really appreciate it. No call next week. Week after that, Michael Flood's got a talk he's going to do, and then we'll figure something out the week before champs, I guess. All right. Thanks, everybody. Have a great night.